Hi everybody, welcome to this training program on transformers. I am J.N. Karamchetti, a graduate in electrical engineering from JNTU, College of Engineering, Kakinada. I have done my MTech in electrical engineering from IIT Kharagpur. I have done a diploma in business and finance from ICFA Hyderabad. I am a certified energy auditor from BEE, Ministry of Power, master trainer in solar roof grid engineer from NISC of MNRE. I have an industrial experience from engineering and development engineer to chief executive in private limited companies, multinational companies for 37 years. I have also experience in teaching and training of engineers and executives at Engineering Staff College of India, Hyderabad for 10 years. We have the present module is O&MF transformers part 12. We have completed about 11 already. And the objectives of the module developed. The author is a qualified and experienced in electrical engineering, power electronics, energy conservation and auditing, design and implementation of solar photovoltaic power plants to share his theoretical and practical knowledge with engineering professionals to improve their skills and in turn to develop India. Operation of the transformer 1. Just commission, leave for 3 hours without loading, adjust offload tap changer to 11 kV position or whatever may be the voltage generally at your place for an average, let us say for about 180 days. Check for earth connection, check for tank body temperature, check for oil leakages after 1 hour, check for oil leakage from the bottom flange of the explosion vent, check for breather with silica gel quantity and color, check for OTI and WTI readings, take readings of voltage, current, temperature, compare with the factory tested certificate, load the transformers and repeat the above. Operation of transformer 2. Transformers and well ventilated place, yes or no. Cooling system is working, yes or no. Primary secondary voltage normal. Loading in kVA, underload, normal load or overload. Check for earth connection, yes or no. Check for tank body temperature. Check for oil leakage after 1 hour. Check for oil leakage from the bottom flange of explosion vent. Check for breather and silica gel quantity and color. Check for OTI, WTI readings within the limits and take readings of voltage, current, temperature, compare with the results what you have already, the FET as well as the previous readings. Maintenance of transformers. The transformer in service should not be subjected to over voltage and over currents. Incoming voltage and taps should be correctly adjusted. Every transformer has a cooling system to limit the temperature rise of the transformer. The loading of the transformer in kVA depends on the temperature rise. Naturally cooled transformers to be installed in well ventilated places. Operating temperature decides the condition for the permissible continuous overload for short periods and overloading during emergency. General maintenance demands cleanliness of the yard and the transformers, immediate attention to oil leakages at top cover gasket, replacement of silica gel periodically, sealing oil should be replaced as and when required, checking performance of radiators, cooling system, equipment and earthing of the transformer should be checked regularly. Contact resistance of isolators and affects the performance of the transformer. Recommendations. General, no work shall be done unless it is disconnected from the external circuits and all windings have been fully earthed. Otherwise, you will have a shock, and this is precaution. You should be very careful about it. Naked lights and flames should be kept well away from the transformer. Oil level should be reduced below tank cover while opening the nuts and bolts on cover and before unsealing the tank. Conservator, explosion vent and any other piping on the tank. Transformer tank cover and other parts should be inspected periodically for oil leakages, peeling out of a paint or rust formation. Recommendations: rust portion should be properly cleaned and painted. Immediate attention to oil leakage. Clamping bolts on gasket joints should be tightened properly, and if necessary, gaskets should be replaced. Leaks through welding joints should be stopped by welding. No oil in the transformer tank and radiator while welding. Recommendations: transformer oil. Oil level should be checked at frequent intervals. Oil for topping up should be clean, fresh filtered, and comply with IS 335. Should be preferably from the same source as the original oil. Refer to Indian standard specifications IS 1866, which gives detailed recommendations for maintenance of insulating oil. Oil to be tested for BDV at regular intervals. Normal method of oil purification, oil maintaining, and dielectric strength. Recommendations for maintenance. Transformer oil IR value does not give a true indication of the correct condition of the oil. Highly deteriorated dry oil may give a dielectric strength. Hence, chemical tests and other tests as given in IS 186 are to be undertaken. Reconditioning by centrifugal separator or filtration, but will only remove sludge, dust, etc., but not acidity, and will tend to retard the process of deterioration. Recommendations: transformer oil. Filters with the Fuller's earth will help to reduce the acidity in the used oil, and in addition to improve the resistivity. Oil of the two different sources, though conforming to similar standards, should not be mixed as the sludgy properties of the oil are considerably affected. Topping of the oil should therefore be done by the original grade of the oil as far as possible. Under unavoidable conditions, the oil should be tested thoroughly before mixing and topping up. Recommendations: conservator and oil level indicator. The lower part of the conservator acts as a sump where impurities and sludge collect. A valve at the lowest portion is provided for draining, and a sampling should be cleaned periodically. All prismatic gauges indicator to be kept clean along with its top and bottom poles. Broken indicator glass should be replaced immediately. Silica gel breather to be inspected frequently, especially in a situation where temperature and humidity changes are considerable. Silica gel in active stage changes its blue, pink, white. Heating it to 110 to 130 degrees for about 8 hours should reactivate the silica gel. The oil level in the oil seal must be maintained at the level marked in the cap. Renew the oil when necessary. Recommendations: explosion vent. The diaphragms at the exposure end and inner end of the vent should be inspected at frequent intervals and replaced if damaged. Failure to replace the outer diaphragm quickly will allow ingress of the moisture, which will contaminate the oil. A broken diaphragm means a fault in transformer, and an inspection of the transformer is essential. Recommendations: bushing. Porcelain insulators and connectors should be cleaned regularly and examined for cracks or other defects. Small or narrow cracks are difficult to detect, however, they are likely to develop rapidly. All such bushings should be replaced on time. External connections, including earthing. All electrical connections should be tight. All spark blackened joints connections shall be disconnected and cleaned thoroughly before being connected and covered by a coat of a grease over the surface. It is particularly important to pay the attention to the connections carrying heavy currents. Gasket. Check the transformer for leakages periodically. Bolts should be tightened evenly around the joints to avoid uneven pressure. Replace broken or leaking joints with proper jointing and fixing at the earliest. And HG fuse and wire importance. This is what we use on the HT side of the 11 kV transformers up to something like 500 kVA. Higher size HG fuse will sustain the fault for a longer period, cause damaging lead of to failure. Use proper size of HG fuse will minimize the damage and the cause of the fault in the transformer. And there is a table is given here, capacities is given, and HP amperes is also mentioned on that. HG fuse size and standard wire gauge is also mentioned. You should always see that what is the capacity of your transformer, what are the amperes as given on the transformer, and that matches with the figure what we have given here. And HG fuse standard wire gauge, you have to buy it, keep it with stock, and replace whenever there is a failure of the fuse. But please don't use the PVC wire of unknown standard and put a bigger size. Bigger size will damage the transformer. HG fuse layout and clearances are very much important in that. Now HG fuse, when you are putting it, there is a distance between that, as you can see in the table A. That gap has been maintained. The bent whatever is given is a very important. The bent is to the outside. It should appear like a horn gap. And the dimensions of D, E, F and A as mentioned in the diagram has to be measured for the particular voltage level. Now, transformer rating and the fuse rating. We have given the left side the transformer capacity is 25, 63, 100, 200, 250, and 500. To the right, next column is the current rating. Next column is the standard wire gauge, which you have to use it. Kindly follow this. Read 2-3 times and follow this. This will help you in saving the transformer without any damage. From distribution transformer connections to the earth pits to one of the earth electrodes on the either side of the DP, and X or Y you can connect it, and one direct connection from 3 11 kV lightning arresters. Now all the lightning arresters at the bottom, they have been already given by the manufacturer a strip. That strip you have to extend it the same size or a bigger size of a GI strip and connect to the directly to the electrode. Don't connect it to the transformer or don't connect it to the structure. It should be taken down. At the down, you have a third electrode you available to you, earth electrode, and give a connection to that. The connection should be proper. It is supposed to carry 100 kilo amperes for 100 microseconds. In case there is a damage to this conductor, the LA itself will blast, and the LA is not anymore in circuit once it is damaged. Please follow all this. Earthing condition to each of the remaining 2 earth electrodes, one separate connection from the neutral of the LV side of the transformer. 2 strips you have to provide it. One separate connection from the transformer body and the handle of the 11 kV AB switch. 2 separate body earths to the tank you should have to give. And one separate connection from the earth terminal of the poles. 4 mm GI wire should be used for the earth leads. Earthing at the double pole structure of the distribution transformer, 3 electrodes from an equilateral triangle configuration, and a minimum distance of each side of the triangle is 6500 millimeters. And earth electrode shall be a grade GI pipe, 5 centimeters thick and 2.5 meters long, buried vertically to leave 10 centimeters pipe length above the ground level. This you can use it even 3 meters also is a better. And if required, you can use always a parallel the pipes instead of increasing the length or diameter of the pipe. Now earth configuration is shown here as a XYZ, and you can see clearly that the distance between them is 6500 millimeters or 6.5 meters, and 2 are marked as a DP structure, and the 2 are marked in a dark with a 2400 millimeter gap. That can, yes, as mentioned it, 2 connections has to be taken independently from the neutral, brought down and connected, one at X and one Y, and the Z can be used for the body. Thank you. This is the end of the part 11. And the next module we have is the transformer maintenance schedule, part 13, that will follow. Thank you very much.